custom delegate only, we are able to achieve the real application performance. All right. So let's do that. We have already, oh, this is multi-threading actually. Let me open the delegate one. Okay, delegate we are supposed to apply today. I think we have not yet created any solution. So let's create a solution. I'm just muting all of you guys. Some sound is coming. So here inside your folder, let me say this. So I created a console application. Sorry. Inside your location. So what we'll do is we will create some function here as usual, but we will not call the function by name. Okay, we will call that function by address or delegate. So the concept we discussed in an Excel sheet. Let me open that Excel sheet as well. Okay, so we don't want to pick and seek the function with the help of name. We want to use address of that function in a delegate, and then using that delegate we have to execute the function. This is what the idea. So let's do that. First we will create one or two functions. Say I have a function below, something like this, static void any functionality you think. Always we are taking void. Let's take integer. I have a function, suppose you send some value to this x and it'll add that value x to some other variable. Let's say I have a global variable here, static void or integer, some num equal to 10, integer. Sorry, I wrote it extremely at the top. It should be inside class. Static integer num equal to 10. So when you declare something in the class level, that become globally available for all the functions. So I have a global variable num. I have a global variable num, and I have two functions. So what I will do, I will write inside this add function num equal to num plus x, and I will return that value num. So try to understand what this function is doing. I have a global variable num which value is 10, and this function I'm writing in such a way that that global variable 10 plus whatever you send to this function x, both will be added, and the new value of sum will be stored. Let's say num is 10 and I'm sending here, suppose add 5. Okay, this is called by function name, isn't it? So we know with the help of name also we can call the function like this. So this 5 should copy to this x. Num is already 10. So 10 plus 5, 15 will be the new value of num. and it will return the new value, that is 15. So that if by chance I'm trying to display the value after that function call, it should show me 15. So here I will say new value after function call is num. And same line, if I will write before function call, somewhere here, one is after function call, one is before function call. So here I will write old value before function call is num. As of now, I have not used any delegate. Simply, I have the function and I'm calling that function by name. So from day one of C# till now, if you see all the examples, usually we call the function something like this, by name. This is called function call by name. Then we will use delegate, and using delegate, we will be storing the address of this function inside a delegate, and then using that delegate, we will be executing the same functionality. So first, without delegate, have a look. This is without delegate, I'm calling a function. Function call by name. So in this coding, anybody is having any question mark what this function is doing? Why this will display 10 in this line, and why this will display 15 in this line? So I'm expecting 10 in line number 12, and I'm expecting 15 in line number 16. Sorry, 15. So any doubt about it? Why here it will be 10, why here it will be 15? Because it's a global variable. So if you are, defining a global variable like this at the level of the class, then it can be used by any function. But if I will write this line here, for example, here, then it's a problem. My add will say, I don't know what is num, because you declared it inside the function main. That's why I will take it and declare it somewhere here. All right. Now let's call it and see. Put a console.read key, in fact, so that it will wait for you. So I'm expecting 2 lines. One is before call of the function, it should be 10, and after call of the function, it should be 15. Absolutely perfect. Right? Now let's replace that with the help of a delegate. So this line is called function call with the help of name. So I don't want that. Now I want to call that function with the help of delegate. So what I will do, I will define a delegate at the top. So if you want to use again the delegate inside this class only, then make it private. If you think your program might be having so many classes, okay, and that delegate can be used inside the class as well as outside the class in another class, then make it public. So it's up to you. You know what do you mean by public. So writing public, which is not mandatory. If I want accessibility outside this class, then you can make it public. But in this particular case, you can take private also, no issue. Then you say delegate. Delegate is a keyword again that you have to mention. Then it will come to know that it's not a variable, not a property, not a function, not a class, but it's a delegate. So that you have to mention delegate. Some rules you have to follow in delegates. Let me tell those things also parallelly here. So we decided to define one custom delegate and store the address of the function and then call it with the help of delegate. So rules to be followed in delegate. First is, obviously we know that delegate is going to store the function address. So make sure the function whose address a delegate is going to store that should have similar signature like delegate. What do you mean? Usually signature means the way of declaring the function. Return type is integer. Parameter is, instead of signature, if you say prototype, that is better. So make sure the function whose address a delegate is going to store, that should have similar prototype, because signature takes only name of the function and parameter list. When we say prototype, that includes all three things actually: return type, name of the function, and parameter list. So I said, if your delegate is having, your function is having return type integer, your delegate should also have return type integer. If your function is having parameter type called integer or float or double, your delegate will also have that. That is what the meaning of this rule. So first rule is, you should declare a delegate whose prototype should be exactly same as your function prototype if you have decided to store the address of that function. So let's declare the delegate accordingly. So a return type, if you see, this add function is having return type integer. So here also it will have return type integer. Then name of the delegate. Suppose name of the delegate is my delegate. DELEGAT, my delegate. It can be XYZ anything, no problem. But the return type should be same as your function return type, and your parameter types should be same as your function parameter types. If they are void, here also it should be void. If they are decimal, here also it should be decimal, and so on. So you can see prototype of the delegate called my delegate and prototype of the function called add, both are same in this case. That is the rule number one. You say it as rule or say it as step, whatever it is. You have to follow this. Second rule or second step of the approach, instantiate the delegate or the custom delegate and push or store the address of proposed function into it. What do you mean? In this program, what is our proposed function? Add is our proposed function. So second rule says, once you declare the delegate with this following of this rule, then the instantiation has to be done. Means kind of object creation. New keyword, right? Instance. So instantiate your custom delegate. That means I'm going to say my delegate obj equal to new my delegate. Something like that it is trying to say. So instantiate custom delegate and store the address of the proposed function into it. So this is called theoretical concept. Practically, we have to write like this. My delegate, whatever the name of the delegate instance, it can be, usually we name obj1, obj2, obj3 in case of object of the class, but it's not class actually. So I'm just using some del for delegate object. You can say it as delegate object, you can say it as delegate instance also. So new my delegate, makes sense? My delegate will have a constructor inside it. It will take one parameter of string type. That means what name you want to supply, so that address of that function, this del1 will hold. So in our case, what is the name of the function? Add. So just pass this add, add. So what is the meaning of this line? Instantiate custom delegate and supply address of the function into it. We don't know address of the function, what is it? We just need to mention the name. Your .NET framework will fetch the address of this add, subtract, multiplication, whatever it is. That function's address, I mean in the random access memory, wherever it might have kept, it will fetch it and initialize it. This is the rule number 2. Third rule, now instead of calling the function by name, execute the function with the help of delegate instance. In our case, it is del1. So wherever you are supposed to write add, add within bracket 5 or 7 or whatever. Now don't do that. It is saying wherever your name of the function you are using, there you use instance of the delegate del1 and pass that 5. Whether 5 or 7 or 10, whatever you want to pass it. That means how many lines we wrote actually? Line number 9, line number 15, line number 17. So if I'm not using them, for example, if I'll not use these 3 lines, usually I use like this. This is called call by function name. But if I'm using, like this, that means instead of 1 line, definitely I wrote 3 lines. Instead of 1 line, definitely I wrote 3 lines. But the performance of our first approach, that is call by name, in a huge multi-threaded environment with multiple users are accessing and thousands of functions are in the stack. If you compare to that situation, then no doubt little coding is extra, but it will not target to name of the function. It will target to address of the function, because del1 itself holds address of the function. del1 itself holds the address of the function. So when I'm saying del1 of 5, it will never search where is add or modify or delete or what. It will say, I don't bother what function it is. Whichever function inside this address, please execute it and pass it with the parameter 5. That's why prototype of the delegate should be same as prototype of the function, because with the help of delegate instance only we are going to call the function. Here we will not say calling the function. Line number 16, we will say, technically, we will be saying executing the function. Executing the function with the help of delegate instance. 3 lines, 3 rules. Okay. Here I define 3 rules. So same thing, 3 lines here. In this line, we are declaring the delegate, which should be same as your, a prototype of the function. Here we are instantiating the delegate. Instantiating the delegate means creating memory for the delegate with the help of new keyword and then storing the address of that function into that memory. So this time it will not store in a stack. This is stored in a heap. There is something called heap. So in heap, it will not go last in first out because it knows the address. So directly it will go to that address location and then fetch the respective function. So let's execute it and see whether how we are getting output before, whether now also we are getting that output or not. So execute it. We are expecting 10 in the first line and 15 in the second line. Can you see? Old value before the function call is this. Or since we are using delegate, instead of writing this sentence as function call, you can say function execution. Just a formality to say that, because call means directly calling the name, execute means with the help of some other element, we are executing the function. So here we say executing the function with the help of delegate. This kind of using the delegate, guys, it is called single cast delegate. So let me write that here. So delegate category, categories of delegate. There are two types. One is called single cast delegate, and one is called multicast delegate. What is the difference? Whenever any delegate has the capability of storing only one function address, then we say that delegate as single cast delegate, having capability or storing only one function address. Of course, delegate means storing the function address. So when it is storing only one function's address, we say it as a single cast delegate. But if any delegate is capable of storing multiple function addresses, storing more than one function's address. Now you'll ask me when we need second category. First category, we saw very simple example. I have a function, I want to call it with the help of delegate. Simple. So I stored the address and then executed it. Now, second category says, by chance you have two things like this. You have something called add, as well as you have something called multiply, suppose. Multiply. Something like this. You have two function or three function or four function, at least two function, more than one, you know. So here, suppose this function is doing some multiplication like this. Any two functions I took. So can I declare only one delegate and it will store address of both the functions? If it is so, then I will say it as multicast delegate. Some rules to be followed here also, if you want to go for multicast delegate. Achha, since one delegate is going to resolve both of them, then it is understood that prototype of the both functions should be same. Don't you think so? Because see both sentence at a time. Here it says, make sure your delegate prototype should be same as your function prototype. In other hand, we are saying here, one particular delegate is going to store both function addresses. So if you compare this sentence and this sentence, you will easily tell that obviously all three, that means both function prototype as well as that delegate prototype, all three should be same. For example, suppose my add function is having integer return type and my multiply is having void return type. Imagine I don't want to return anything like this. Both of those functions cannot share a common delegate. Repeating again, both of these functions cannot share a common delegate. That means a single delegate cannot hold address of both functions. Simple to understand, right? Definition says your prototype should have same address, your delegate should have same prototype as function. In other hand, you are expecting two function or three function address should be stored in a single delegate. Then obviously it is understood that both functions should have same prototype. So luckily I have suppose both function same prototype, same return type, same parameter type. That is called same prototype. If it is so, luckily in this case I can use only one delegate instance to hold address of both functions. Right? So let's try that out. This is called multicast delegate. DEL1 is a single cast delegate instance. DEL1 here is a single cast delegate instance. Similarly, I can create one more single cast delegate instance like my delegate DEL2 equal to new my delegate, and I supplied multiply. Multiply is the name of the function. Then perhaps I call DEL2 of 5, suppose. This is called using two single cast delegate. DEL1 is one single cast delegate instance. Similarly, DEL2 is another single cast delegate instance. Let me write that here. In this example, both DEL1 and DEL2 are single cast delegate instances. Make sense? We have not yet created a multicast delegate. I created two single cast delegate. One is targeting to address of add, one is targeting to address of multiply. Now you tell me, we will go to next level, multicast delegate, but first you tell me, by using this two single cast delegate, first I executed add function in line number 16. Then I executed multiply function in line number 20. Are you agree with me? If you understood single cast delegate properly. Now you tell me, here also I am sending 5. Here also I am sending 5. Actually, always your compiler comes from top to bottom like this, like this, like this, like this. Okay. So here it will display 10. I am dead sure. But this time I call two functions one after another, isn't it? First I called add here, then I called multiply here. So my question for you is, in line number 23, what will be the output? If you are understanding systematically, what will be the output in line number 23?
75, sir.
Okay, anybody else? Wake up, guys. It's already 7 o'clock. Yeah, anybody else? Here it will call first function. Here it will call second function, right? Obviously with the help of delegate, but actually it will call, right? I could have written like this also. What is there? Add 5, multiply 5. Only difference is here it is called call by name. That is called call by delegate. Apart from that, nothing difference, right? Execution wise. Maybe this will be little slow. That will be little faster. That's fine. But tell me like this also. Forget about delegate if you are confusing. If like this also I will call, what will the output in the line number 19? One student said 75. Anybody else thinking differently? Or even agree with same 75? Anybody? Yeah. Whether it will be wrong, who is going to kill you, guess? You should try it out, right? It's just a function call. Who is that writing in the chat window? Why so hesitant to speak in front of everybody? Sangam and Ankur. English only I'm asking, right? Not in Telugu. You can unmute and speak. Yeah, anybody else? 75, absolutely 75. That's correct. So it went to add, it made 10 plus 5, 15, and then new value of the name become 15, and then in this line, it took again 5. So new value of num is 15 already, and x value is 5. So 15 into 5 equal to 75. So let's run it and see really whether it is 10 and 75. This is called call by name. Okay, how many times I'm deleting those and writing again the common approach so that you can take it easy. So no need to take delegate as very difficult thing. Understand perfectly, so that you need not to remember a lot of things. It is function call by the name. That is function call by the address. What's a big deal? Store the address and call it. And for better practice, we say it as executing, because indirectly calling the function, that is why we say executing. Directly calling the function, we say name of the function or call by name. So if I will execute this way also, it will give me 75. And if I will call this way also, it will give me 75. Right? So let's call it, execute it and see whether really in this line it is giving 10 and in this line it is giving 75. What calculation happening, that's not a big deal here. Here those 3 steps you have to remember. How to declare, how to instantiate and store the address, and how to execute. So have a look, 10 and 75. Okay. So this is done. Still, we will say it is 2 single cast delegate, isn't it? DEL1 is a single cast delegate and DEL2 is also a single cast delegate. This is single cast delegate. What I will do, you should know both of them, right? So here I will write using single cast delegate. Then what I will do, I will copy paste this once more and I will modify as per multicast delegate. So multi-line comments, right? Slash star star slash. If you don't want to disturb some existing coding, you keep it inside a comment. Then copy paste it once more. Okay. Anybody confusing? Please raise the hand and speak to me. So I copy pasted because I don't want to disturb single cast delegate process. Now here I will give the heading using multicast delegate. Because after 1 month, suppose you are referring this, if I might have deleted all this and taken the multicast delegate, then at the end your solution might be having only multicast delegate. So I want both should be there. So just a minute, guys. Thanks. Your phone call is coming. Hello. Yes, Satya. Good morning. Yeah, I'm inside class only. Yeah. They have to come. Yeah. Sorry, guys. So, what I was saying a single cast and multicast. So, I don't want to disturb the single cast delegate process. That's why what I did, I commented that area so that whenever necessary, you can, refer the code. Now, after copy pasting, I will, modify whatever modification I want to do for multicast delegate. So idea is DEL1 is my single cast delegate. DEL2 is also my single cast delegate. I will define one more delegate instance now. Okay, I will define one more delegate instance now, which will have, addition of DL1 and DL2. Let me try that out here. I will delete this line. And I will delete this line also. That means I declared two single cast delegate first of all. That means without using single cast delegate, you cannot work with multicast delegate. So I defined two single cast delegate. First one is having address of function number 1. Second one is having address of function number 2. Simple. Then I will define one more delegate instance. My delegate, say DL3. Just like x equal to y plus z or z equal to x plus y, I said DL3 equal to DL1 plus DL2. It is not really adding any value. It is adding two addresses actually. So here what it is doing? Here it is combining. Adding is not a good terminology. When 10 plus 20 equal to 30, you are saying adding. When 10 plus 20 equal to 1020, do you say adding? No, you are saying combining or concatenating like that. So here it is combining DL1 address and DL2 address, indirectly function 1 address and function 2 address, and stores in same sequence in DL3. What do you mean by same sequence? Left to right. If first I have kept DL1, then I have kept DL2, then by chance if I am executing DL3 and I am sending 5, then what will happen? First it will execute DL1, then it will execute DL2 in the same sequence. That is the meaning of same sequence. If by chance here I will write DL2 and here I will write DL1, for example, then what will happen? In this line number 34, first it will go to DEL2. DEL2 means indirectly saying multiply. Then it will go to DL1. That means indirectly saying add. So first it will execute multiply, then it will execute add. Output in this sequence and output bottom to top not will be same, right? It will never be same. First you multiply, then you add. What output is coming? First you add, then you multiply. Output may be different, right? So you have to understand that what is your sequence of execution of the function. So let's take DL1 and DL2 only, because just 5 minutes back we executed single separately and we got 10 and 75. Whether same thing we are achieving here also, we have to cross check. So without any of this, if I am simply writing add 5 multiply 5, output is same. Then I tried like this. One single cast delegate DL1, one single cast delegate DL2, separately called DL1, separately called DL2. That also I observe. Output same only. Because output should not be different, right? Why we are learning all this? Do you think for changing the output? No, for improving the performance. So performance improvement doesn't mean that changing the output. Suppose your radius is 2 and you are calculating pi r square, area of the circle. How much output it is giving? If somebody else told you some other approach, will the output change? No, right? Output should be same. Only the performance we are targeting for. So this is the poorest performance. This is little better than that, definitely. But this is the fastest one. But if you have only and only one function, why should you go for multicast delegate? You should go for only single cast delegate. But if you have more than one function, and luckily all the functions are having same prototype, then only you can opt multicast delegate. Not only prototype, one more rule is to be followed up. Let me write that here. Mainly multicast rules. So rules to be followed up in multicast delegates. Rules to be followed up in multicast delegate. First rule, the common rule, which we have already discussed. Prototype of the all functions should be same as that of delegate. So prototype of all functions participating in a multicast delegate should be same as that of delegate. Okay, point number one. Point number two, each of the function should take same value as argument. Try to understand this. In my first approach and second approach, first approach was what? Call by name. I could have called with 5 to add, 7 to multiply. Nobody can stop me. Okay. Similarly, in second approach also, which is called using delegate but single cast delegate. This is the one. I can pass here 5. I can pass here 12 also, no problem. Line number 22. Line number 18, I passed 5. Line number 22, I passed 12. Absolutely fine, because I don't want same value everywhere. Please add with 5 and multiply with 12. What is there? Absolutely fine. But third approach says you cannot do that. If that is the case you want, multicast delegate is not fit for you. Try to understand. If you think add is taking some 5 as input parameter and multiply is taking some 7 or 10 as input parameter, both are not having exact same value as input, then multicast delegate is not for you. You can go for 2 single cast delegates, no problem. Little bit enhanced performance you will get comparing to call by name, but multicast delegate is not for you. So usually what happens here, 6 2 times, picks 2 times, but here it's 6 only 1 time, it picks 2 times. That's why this is faster than even single cast delegate. But unfortunately our rule is not matching. You are saying I want to pass 5 for first one, 7 for second one. Then obviously you cannot do this, because in one line only you are calling both the sequence of the functionality. You cannot give something like 5,7 or so. Not allowed. It will say whatever you decide, you give it here. Both should have same prototype and both should take exact same value as argument. That's why practically saying in real-time industry, work, real-time project development work, very less chances you will get where multicast delegate will be useful. But it is our duty to understand because these are all categories. At the same time, you have to remember these rules also. So each of the function should have same value as the argument. Then only your multicast delegate is qualifying at least. Otherwise, you cannot use it. So let me write that also. Otherwise, multicast delegate cannot be used because first function is saying my argument is 5, second function is saying my input parameter is 7 or 10 or 20, like that. So otherwise multicast delegate cannot be used. Rather, use two single cast delegate. So two single cast delegate means you have full freedom. You can say, hey, first function I will pass as argument 7, second function I will pass as argument 25. No problem. It depends upon you. But if that is not the case, exact same, then you have to go for single cast delegate or call by name. But call by name is taking maximum time consumption because it follows of the function stack. So 3 ways of calling the same function. Call by name because you don't know delegate. Call by single cast delegate because you have either only one function or we have multiple function with different prototype or different argument. Then you have to go for the second approach. But luckily, if everything same, prototype also same, argument also same, and that is also matching with the delegate prototype. If luckily everything same, then the best way is multicast delegate. So, any question mark, guys? So let me run it and see whether we are achieving same what we are achieving, in previous two cases, 10 and 75. Because output should not be changed, right? If output changed, then no use, right? Performance is totally different than the output. So you are giving one employee ID and getting the employee detail. Now, because of enhancement of the performance, if it is taking employee ID 25 and giving you employee detail of some other guy, you will not be happy. Performance is the second priority. Output should be the first priority. So output I want 10 and 75, that is more important here, definitely. But on top of that, how in 3 different approaches we can, call those functions, that is important here to understand. So first one was call by the name. That time you understand that you don't know delegate. Or perhaps you don't need delegate. What do you mean? Perhaps I have only 1 user or 10 users, something like that. And it's a standalone computer where my application is running. There is nothing like today it is 10,000 user parallel, tomorrow it will be 25,000 users parallel. I have no idea how many function will come to the function stack and it may take more time. So if that is the case, rather I will suggest simply call by the name of the function. No need to go for delegates. Then second case came, if any of those situations is, occurring like multiple users at the same time, we have no idea how many users will come. Only we have idea is one user uses 3 functions. But who knows, there will be 50,000 users. So 50,000 users means 1.5 lakhs functions will suddenly come into the function stack. Each individual is executing the function with pick and execution time. So to reduce that timing, we saw how to use delegate at least. Then we saw delegate is of 2 types, single cast delegate and multicast delegate. Single cast delegate when either there is only one function or there will be multiple functions and all functions are having either different signature, different prototype or different value as argument. then you should go for so many single cast delegate only, which is the category number 2. And category number 3 comes, luckily, maybe one case in 1,000. All functions are of the exact same prototype. All functions requires exact same value as argument, and that is same as your prototype of the delegate. If that is the matching case, then you should go for multicast delegate. So at least 3 to 4 times I have repeated this. The reason is important from interview point of view also, and from performance enhancement point of view also. If in future you are a developer and suddenly your customer is calling you and saying, dear, when traffic is increasing, then my application is dead slow. Can you do something? Quickly your mind should click on this area. But if he's saying, forget about multiple users or traffic, I'm a single user only, not yet gone to production environment. It is in my computer only. I'm executing, but it is dead slow. No need to think about delegate, guys. Delegate is not for you that case. Maybe your database connectivity or your approach in C# coding, somewhere else you have to enhance the performance, not in delegate. So delegate is only applicable where you are thinking function stack is overloaded, because delegate is holding only function addresses, remember. So like that, you have to be matured and you have to take a call whether my delegate is going to improve the performance in this case, or somewhere else I have to think for. Going forward, you will see a lot of things. Stored procedure in the database side, database best practices, C# best practices. A lot of things are there to improve the performance. But this is one of them, you can say. Only if your function stack is overloaded, when traffic is much more and your performance of the application is dead slow, then you should be doing this kind of approaches in your coding. So out of 3 advantages, extremely top, we discussed about advantages, right? Out of 3 advantages, what is 3? Asynchronous, event-based delegate, and enhancement of the performance with the help of custom delegate. So 2 things we already saw. One is how to use asynchronous methodology. In other words, we say multi-threading. And we just now saw through both single cast and multicast delegate how to enhance the performance of your coding. Third one, this one, have a look. Event-based delegate. There is something called event. You have a button, suppose. Click is one event. You have a drop-down, suppose. Selection is the event. You have a text box, suppose. Mouse click is one event. Typing also is one event, like change of the content. Coming out of the text box, you press tab button in the keyboard and you are coming out of the text box. That is also an event. So any action related to any control is called one event. Control means button, radio button, checkbox, drop down, text box. All these are called controls, form controls or page controls. So any action happened on the controls. Even if you don't have anything, you have a blank page, guys. That page itself is also a control. So any event, like I said load the page, that is also an event. I said click on the page, that is also an event. I said close the page, that is also an event. So any action on controls is called one event. Now event is also stored in delegates. If delegate might not be there in industry, remember, perhaps event-based function call might not have been possible. Event-based function call, remember. I defined the function now, but I don't want to say call the function now. I will say in future, whenever my user will click that button, then you call that function. But in C# console application, if you are calling the function, it is calling then and there, isn't it? Does it remember something? Hey, I will not call now during execution. Somewhere in future, somebody will click the button, then only I will call it. Or somebody will select the drop down, then only I will call it. Nothing like that in console application. So since it is related to event, and event is always the action of the controls, we will be implementing this third facility of the delegate in something called event-based programming in ASP.NET. Okay, so two advantages already we got. One is asynchronous or multi-threading way, one is custom delegate way, but third one we will be using in ASP.NET. So now we will stop here. We will not use event-based delegates, but when it will come the time how to define a button, how to define a drop down, how to define a text box, that time I will tell you, okay, we defined the text box or we defined the drop down. Now we want to define some event functions. What are all points to be remembered and how to push the address of that function. Say it is button click, say it is page load, say it is text box changes, say it is drop down selection, whatever the function name, how to store the address of that function into a delegate called event-based delegate. So a delegate that stores the event function address is called event-based delegate. So practically you can visualize actually the impact of that in one GUI platform, graphical user interface platform. Say it is MVC, say it is, ASP.NET, anywhere. Say it is PHP, say it is Java, but actually in some user interface, you will see that impact. So remember this in ASP.NET when we will go for event-based programming, that time we will see again how to use third advantages of delegate. All right, so we will stop the class here. Any question you have, guys?